Hey everyone, welcome back to Stat and Research 2. I hope you're having a good morning, afternoon, night. Whenever you're watching this, I hope you're having a great day. This week, we're going to be talking about subsampling designs, and there's 4 pretty short videos along with R and jump help. But before going in and talking about subsampling, let's just remind ourselves about some deadlines and some due dates. So first, homeworks are due on Saturday, normal. There are a lot of extra credit opportunities for y'all that are due Wednesday, March 3rd by midnight so that I can release the answers so that we can have a great discussion in our live Zoom session on Thursday, March 4th to help us prepare for the exam, which is March 8th through the 12th. And again, you'll have that entire week to take it, but once you take the exam, there will be a fixed amount of time. That's it for our class announcements and kind of deadlines. If you can't remember this, always go check Canvas or Slack and you'll be up to date. So let's get started about talking about subsampling. So again, this week we're going to be talking about subsampling designs. Specifically in this lecture, we're going to be motivating and understanding what a subsampling design is through understanding kind of stuff we've already talked about, redefining what EU and OU are, and then going through an example. So let's get started. Again, the objective of an experimental design is to understand the effect of the treatment on the response. And we've talked about error-controlled designs, which is the protocol to identify and account for systematic variability. Beyond that, due to the treatment differences. And we've talked about that through breaking up our experimental error into systematic variability and unexplained variability through these couple designs, where our systematic variability is like our treatment variability, our block, or our interactions. We've also talked about treatment design, and last week we really expanded on this through talking about the factorial. Previous to last week, we only had one treatment, and again, treatment design is how many treatment factors do we have? What are the levels? Are we going to use all the combinations or only a fraction of the combinations? In this class, we didn't worry about the fraction. We were just focused on all of them. And our treatment design can be combined with any error-controlled design. Now, in this lesson, we're going to be focusing on subsampling designs, which is the protocol for measuring responses of observational units. And we can add the subsampling design into a treatment design and then have a treatment design into an error-controlled design. So that's pretty cool. So let's just recall, this is also good practice for our midterm coming up. Let's recall what an experimental unit and an observational unit is. So the object to which treatments are randomly applied are our experimental units, and the object from which the responses are measured are our observational units. Okay, so if we recall one of our shrimp examples from lesson 1, we set water temperature and saline for an entire container of shrimps and then measured the weight of the individual shrimps. So visually what that looked like is we had a container here and we set the water and saline, and then we had little shrimps. That's what a shrimp looks like in my head on a cartoon. And we measured the weight of this shrimp and we measured the weight of that shrimp. And so in this case, our experimental unit would be the container, because we applied our treatment of saline and temperature to the container of water. Our observational unit is the individual shrimps, because we're measuring the shrimp's weight. Okay, in lesson 1, we also defined replication and subsampling. Now recall, replication is going to be the duplicate of treatment assignments to the EU. So replication and subsampling is the duplicate of OUs. So if we came back up to this shrimp example, we had this container, which we applied, let's just say warm water and 10% saline. If we were to have another container that we applied warm water and 10% saline to, this is a replication. Our subsampling is the two shrimp in this replicate. And we'll get into more of this in our car example today. So in a subsampling design, we're taking multiple measurements of every experimental unit, which is going to imply our number of OUs is going to be greater than our number of EUs. We can apply our subsampling design to error control designs and treatment designs that we've talked about before. But the overall idea is that we have multiple observational units per a experimental unit, then we'll have a subsampling design. So in our class, we're going to only be focused on subsampling in the CRD case. So let's go to an example. Our car mileage example, researchers are interested in comparing gas mileage among 5 different brands, A, B, C, D, and E, of cars. For each brand, 2 cars were randomly selected from a dealer's lot. Then each car was filled with gas 3 times, and then they were test driven under identical circumstances to determine the mileage. So in this case, our experimental unit is going to be the car. Our treatment that we're applying is the brand, and then our observational unit is still going to be the car because our response is the mileage. Okay, so we have car 1, car 2, and with brand A, they have 3 test drives. That is, we're taking the exact same car and we're driving it 3 times. So subsampling is giving us more precision. These subsamples right here are giving us more precision among the measurements of our observational unit. Now, if we had 3 different cars, so instead of this car driven 3 times, we had car 1, car 2, car 3, only one measurement, only one measurement, only one measurement, then that would be replication. Here, we have subsampling because we would expect these 3 observations to be the same. And if there's any difference among these 3 observations, it's within the same observational unit that we're getting the duplicate from. Okay, so in this example, we have S equal to 3, where we're going to let S denote subsamples. And we're going to have N, little n, which is our replicates, which is 2. So what's happening is, let me give a little illustration maybe to help clear this up. What's happening is we have a car 1, brand A. We fill it up with gas. This is my best gas tank. Fill it up with gas, and it's going to drive around, and we're going to get a measurement of mileage. And that's going to get us this right here. Then we're going to fill the same car up. It's going to drive around again, and we're going to get a second measurement right here. Then we're going to do it again. Same car, so same experimental unit because we only applied brand A. Fill it up, and then it's going to drive again one more time, and we're going to get this 3rd measurement. Okay? Now, for this next car, for car 2, we would get a new car. Push this up a bit. we'd get this car number 2A. We would fill this up 3 times, get that one, fill it up, get that one, fill it up, get that one. So we're getting 3 measurements from the same car or the same experimental unit, okay? Now in our next lecture, we're going to be talking about how do we analyze and all that. But really we have 2 options for analyzing this type of data. Our first option is to average over the measurements. So in this example, if we were to average these 3 numbers, we would get this number. And so we're just going to average over our subsamples, and this would just reduce to a typical completely randomized design analysis ANOVA that we've done before. Option 2, I'll fix that on y'all's. Option 2 is to do a subsampling analysis. Taking this approach is going to be more effective use of our available data, and it's going to allow us to be able to treat unbalanced subsampling. That is, maybe if we come back to here, maybe this car broke down and we weren't able to get that measurement, and so that measurement's missing. Doing an analysis with the subsampling design will allow us to treat for that unbalanced case. So in this lesson, pretty much recap, we reintroduce subsampling. Subsampling is the duplicates of observational units, which allows us to evaluate the measurement error. So in many cases, adding subsampling could be cheaper than adding replications. For instance, driving a single car around 3 times is probably cheaper than getting a whole brand new car to drive once. But subsampling doesn't give us as much information as another replicate could. So here we just talked about subsampling. In our next lecture or lesson, we will be going through the statistical model and the ANOVA to help us learn how to analyze this type of design.